In this section, we will discuss network operating system configuration and storage options. Let's start out by discussing security policies and group policies. A group policy is a configuration variable, and a group policy object is a configuration file which sits on the domain controller, but which can be used to configure every computer and every user in the organization. But let's talk about what happens if you don't have group policies. Let's say you want to install Microsoft Word and you want to disable the USB drive on every computer in your organization. Well, doing that to one computer doesn't take that long. But at CCBC, we have 5,000 workstations. So to walk to every single workstation to install Microsoft Word or to disable the USB drive or to do whatever it is we want to do, to walk around to each individual computer is awfully labor intensive and time consuming. So what we do is we use group policy. A group policy object is a configuration file which is located on the domain controller, but which applies to all users and all computers in the domain. Instead of manually walking around to each computer to configure it, you configure the domain controller and it pushes those configuration variables down to the users or the workstations. Group policy can be used to configure user properties or computer properties. An example of user configuration properties might be to change security parameters such as login parameters. And the point is, we do it once on the domain controller and it applies to all users in the domain. If we go to the domain controller and we go under security settings, under account policies and password policy, we can configure such that the user has to reset his or her password every 180 days. And since this is on the domain controller, then it applies to every single user within the domain. Group policy can be used to configure every computer in the domain. It can be used to push software down to every single computer in the domain. It can be used to disable the USB drive on every computer in the domain. So here's how we would do that. We would go to the group policy editor for computer configuration policies, and we would select device installation restrictions, and under prevent installation of removable devices we would click on enable, and that would enable a policy which would disable the use of USB drives, which we might do for security purposes. So a group policy object is a configuration file which sits on the domain controller and which can apply to every user and every computer in the domain. Centralized storage. Where can data be stored? You can store data locally, on the company server, on a storage area network, or on a cloud server. When we say saving files locally, that means you're saving files to the hard disk of the computer where you are currently logged onto. So if a user comes in one day and goes to a workstation and types up a file and saves it to the hard disk, and then the next day logs onto a different computer and tries to open the file, the user is going to say, where are my files? And you would tell the user, well, they're on the hard disk of the workstation which you were logged into yesterday. What you should really do is save files up to the server. So you tell the user, save files up to the file server hard disk. And that way, if you log into another computer the next day, those files will still be available to you regardless of the workstation you log on to. A home directory is the folder on the file server hard disk where users can save files to. So when the user Bob saves a file to the home directory, he's saving it to the Bob folder, which is located under the users folder, which is on the file server hard disk. If we look at the user Bob's user account properties under the home folder, we can see that the user's Z drive is mapped to server 1 to the user's folder to the folder that corresponds to the user's name. So that way, if the user saves to the Z drive, he is actually saving up to his or her home folder centrally located on the server. When the user saves to the Z drive, he is actually saving to his home folder, which is located up on the server. And that way a user can log in from any workstation. A shared public folder is a folder that many users can access. Now, in my previous example, Bob and only Bob can access his folder up on the server. But you could also have shared folders on the server which can be accessed by many users. And the reason you do that is so many people can work on the same project together, and when many people are working on the same project together, that is called collaboration. So a file server is a central storage location that has shared folders on it. And there are two types of shared folders: a home folder, which is only accessed by one person at a time, or a public folder, which can be accessed by multiple people. Now let's discuss what's meant by a storage area network. Let's look at traditional local area network storage. In a typical local area network, the disks are located in the servers. And the problem with that is that can be a little inflexible. So here's the example. To the left here is the local area network, and these are the users at their workstations. And that connects to a switch, which connects to another switch, which is in the server room. And these are the servers, and they are all together in the server room. And in this example, each server has 2 hard disks in it. Now, what if I want 3 hard disks in the first server, and I only want a 1 hard disk in the second server, and I only need half of a hard disk in the third server? It would be a lot of trouble to turn off all of these servers and to start moving disks around, and I really can't cut a disk in half. So what we do is we get a storage area network. A storage area network is we get an external disk array. Sometimes they call it a RAID array for a redundant array of integrated disk drives, but more accurately it should just be called a disk array. And instead of having the hard disks in the servers, the hard disks are in the disk array. And then a high-speed switch connects the servers to the disk array. So the storage area network is all within the server room. And then what we can do is we can allocate, for example, 3 hard disks to the first server. We could allocate, for example, only 1 hard disk to the second server, and to the third server we could allocate only half of a hard disk worth of space. Here is another diagram of a storage area network. In a storage area network, the servers connect by way of high-speed switches to the disk array. In a storage area network, there are no disks in the servers. I mean, there could be, but usually not. There is a single disk array. Of course, there could be multiple disk arrays. And the servers connect to the disk array, and then disk space is allocated to the servers. The reason we do this is it is a more efficient allocation resources, and it allows many servers to access the same file, which can be useful when it comes to server failover clustering. Now let's discuss cloud-based storage. When we say the cloud, we mean the internet. And a cloud server is a server which is connected to the internet and which can be accessed from any computer which has an internet connection. So if you are at Starbucks and you are using your laptop computer and you're connected to their wireless network and you're working on a file, you can save it up to a cloud server, such as a Google Docs server. And then if you go home, you can still access the file on the cloud server. If you go to work, you can still access the file on the cloud server. A cloud server is simply any server which is connected to the internet, which can be accessed from any other computer which has an internet connection. And the one reason we like a cloud server is it allows many people to work on the same project at the same time. People in San Francisco and New York and Miami could all work on the same file at the same time, and that is called collaboration. So data can be stored either on the local hard disk of your own local workstation. It can be stored centrally on the company file server. It can be stored on a storage area network, or it can be stored up on a cloud server. Now let's discuss infrastructure server fault tolerance. Previously, we've been talking about file servers, but an example of an infrastructure server would be a domain controller or a DNS server. A domain controller is often called an authentication server or a login server, and a DNS server performs host name resolution. Well, what if either one of those server crashes? What do we do for fault tolerance? And the answer is replication provides fault tolerance. We have more than one domain controller, and one domain controller replicates its contents to the second domain controller. It copies its contents to the domain controller, so the domain controllers have the same information on them. They don't call that domain controller mirroring, but it would not be a bad term. Similarly, we have multiple DNS servers, and the primary DNS server periodically replicates to the secondary DNS server. And if either DNS server crashes, that's okay. We have the other one. Replication provides fault tolerance. Now, some servers, such as email servers, web servers, SQL servers, do not provide replication. So we have to achieve fault tolerance by using server clustering. Server clustering provides fault tolerance. It's where you have two identical servers, and the first server is operational and the second server is just a standby server, and it doesn't do anything until the first server fails. And when the first server does fail, then the second server kicks in and it responds to user requests. The way the second server knows that the first server has crashed is that periodically the first server sends a signal to the second server, and that signal is called a heartbeat. And if the second server fails to receive a heartbeat from the first server, well, that means the first server has crashed, so then the second server kicks in and starts responding to user requests. Another form of fault tolerance is RAID, which stands for Redundant Array of Integrated Disk Drives, and an example of that is disk mirroring. Disk mirroring is when there are two hard disks in the server. And when a user saves a file, the file goes to the second hard disk, and the user doesn't know it, but it is immediately copied to the second hard disk, and the first hard disk is a mirror image of the second hard disk. And if either hard disk crashes, that's okay. We have the other one. This provides fault tolerance for the hard disks, and RAID and disk mirroring will be covered in greater detail in Chapter 12. So you can see you can have fault tolerance at the component level or at the unit level. When we say the component level, we mean a component of the server, such as disk mirroring or network interface card teaming, whereby you have two network interface cards in a server, and if either one crashes, that's okay, you have the other one. And you can have fault tolerance at the unit level, and a unit means a server, and that is provided with either server replication or with failover clustering. And this concludes our section on server configuration and storage options.